Let's consider the type checking part of our extended curly language. So type check has to deal with the let type form. And in let type, for this first part, there's not much that can go wrong. We can put any type here, we can put any variant names we want, we can put any types for the fields of those variants. As long as those are well-formed types, all of that is okay. And then the main work is just type checking the body of the let type. Because whatever the body returns, that's what the let type form returns. So the type of the body is going to be the type of the overall let type expression. If we put 1 in the body, then the type in this example is going to be numt. But let's put something more interesting here. Let's put apple1. And in this case, the type checker sees an application form, but it's applying a constructor. And so it will need to have a type for this constructor here, apple. And that type, that let type needs to set up, should say that it takes a number and returns a fruit. So the type of 1 is a number type. That's going to be consistent with the field type. And the result type fruit, that comes from the fact that we're using the constructor apple. So we represent the type fruit as defined tfruit. It's the same if we write banana down here. Apple or banana are both constructors for the fruit type, so whether we use one or the other, we'll get a fruit out. If we have a type case form in the body of the letrec, then we can start looking at how type check works with type case. To check a type case, it needs to make sure that this name, this type name fruit, is defined. And then it also needs to check something about this expression and the right-hand side expressions. Now, when we run this, we know that apple3 is going to cause it to match this case and return the number 3. So this numt result is consistent with what we expect. But at type checking time, we don't run this expression, so we don't know which of these variants are going to be hit. It could be that we come here to B7. If we do, then we know B, being a field of banana, must be a num arrow num, so applying B to 7 will give us a number back. And that's good. For type checking type case, we'll need to make sure that all of the possible results here have the same type. Now, how was it that we figured out that A was of type number? It's because there's a reference to A of the field, apple. Apple is a variant of the fruit, and that first variant of fruit is declared to have a field num. So the let type form is going to need to put into the environment information about the fruit type. For example, if we had this other case where we have type case fruit radish, then type case will need to look up the information about fruit and check whether radish is one of the allowed variants. And since it is not, then that's why we get a no type here. So in type checking let type, we don't just need to type check the body, we need to put in the environment information about the type that is defined, like fruit. And that information needs to include what are the variants that are allowed and what are the types of those variants. Here's another bad case, for example, where we need the information that apple and banana are both allowed variants, but here I'm just returning B instead of applying B. So because the environment records information about this type num arrow num, then that's how I know this is num arrow num and this is num, and those don't match up, and that's why there's no type. So overall, let type needs to record information about the type name, its variants, and what are the types on those. In addition, it needs to record that apple acts like a function from numbers to fruit, just as we saw in those earlier examples.